Hello, everybody. It was very nice meeting majority of you in the class today. As I said at the end of the lecture, I'm going to make a short video to complete the today topic. At the beginning, I'll do a quick review of what we discussed in a few minutes and finish off with the rest of this lecture. I will post the annotated slides for you. Later, I will post another video for chapter 2. And again, as I said, this is more an introduction to chapter 2, a video lecture for you to watch that prepare you to do assignment 1, which is due this, I believe, Saturday or Sunday. And also you will do an important quiz this Friday. This quiz online, and you do it at home. It is 1.5 hours, start from 8, and you have to finish it by 9:30. The quiz is an important quiz that helped me to understand the level of the course, the level of the class, and how to navigate the rest of the term. It's a very simple quiz with multiple choice questions, and you can read more details on Canvas. But let's finish off the rest of today lecture. All right, so I'm gonna share my screen here for you. Sharing screen. All right, should be good now. Going there. Perfect. All right, I'm just going to quickly turn off the light here. Okay, it's better now for me to write. I'm going to do my best to explain the details, but it's not like a real classroom because you're not here to ask question. However, we have office hours that you can ask question later, and I'm going to review these topics later several times in future lectures in the class as well. All right, we said that the topic that we are interested to study is on mechanism. A study of mechanisms are important because in a manufacturing setup, as we discuss it in the class today, you're going to see a lot of mechanism. I showed you a video simulation of injection molding machine, and you saw the clamping mechanism there. All right. Moving on. Just gonna set up my things there. All right, that sounds good there. Okay, so in the class, I showed you a simulation of a slider mechanism or a crankshaft mechanism to be exact. And a crankshaft mechanism is made out of a lot of components that in this course we will study them in more details. We talk about it in the class. Now, if I hide the some components that we don't need them now for the discussion today, we're going to left with these components, and we said in the class, and as you can notice in this mechanism, there are components like these crank, the connecting rods, and the cylinder and piston, and that they moves, but the bearing, that green part, and the cylinder, they are not moving. An important factors that I want to talk about is if we look at the side view of this mechanism, we can see now a 2D mechanism. So in this course, we are going to deal with a lot of 2D mechanism, but in real world, we have actually a 3D mechanism. However, we can simplify them and treat them as a 2D mechanism. Going back to the lecture slides, we talk about here in details, and you saw that around this axis, we have an omega, the rotation. And then I showed you that actually we will analyze a mechanism using links or a simplified model of that. So what we did together, we draw this mechanism on top of the actual mechanism. And if I move it back there, we'll see the same mechanism. And actually, this is the mechanism that we will see a lot in this course. So this is the crank, the connecting rod, the piston, which I showed it as more like a square shape here. And you see the two constraints here. Those are the piston there, right? So it tells us that the cylinder can move, the piston can move ups and down. It cannot move left and right. And then we saw together a four-link mechanism. We call it a four-link mechanism because we said always the ground or the table is link 1, and then you have link 2, link 3, and link 4. And you saw depending on the geometry, you may have different behavior from this mechanism. For example, if you have a complete rotation omega here, then link 4 in this mechanism may have a swinging motion, right? This is another four-link mechanism, and this is another one that I just drew it for you in the class. And you see link 1 actually is that link or that part of the ground that we don't show it. And then we have link 2, 3, and 4, and this is a mechanism there. So two important mechanisms that we introduced today. One was the slider mechanism, this one, the slider mechanism, and this is a four-link mechanism. We're going to study them a lot. I showed you a simulation and video or simulation in a software, which we said this is an important software that I'll teach you how to use it later in the class. As you saw, I built these models and we can see the animation, and later we will learn also to analyze the motion and see the result of this mechanism as well, which is a topic for later. All right, going back, continue with our discussion. We talk a little bit about some terminologies. First of all, before I forget, earlier in the lecture, we talk about the difference between machine versus mechanism. Right? And you can check it online as well. But in simple words, machines are a bunch of mechanisms that they do something for us. So we have maybe a motor or something that creates an action like an engine in a motor. So that makes a machine. But and that's why the name of this course is Machine Dynamics. So we'll focus a lot on mechanism in this course. And the moment we give a mechanism a motion, for example, we attach a motor to it so it moves, it becomes a machine. So linkage. Linkages are mechanisms that all the members are free. Now, similar to example one that I showed you, if I fix one of these members, now I have a mechanism. So I have now here link 1, which is part of the ground, now attached to the ground, and we use this sign here to tell people that it's being fixed to the ground. And then I have link 2, 3, link 4, and 5 is a plate, a triangular plate here, and 6, 7, and 8. So this mechanism made out of member 1, which is a plate. All right. It's not a link, it's a plate. And then we have the rest of the linkage and plates 5 and 6. All right. And we'll also discuss about this example in the class and how it works. Moving on, we discuss with more details this slider mechanism. One of the members we said is fixed. Again, going backward a little bit here, we'll see this is the copy of the same mechanism. And we talk with more details that pay attention is member 4, this member 4 here. If I fix link 1, this member 4 now is constrained to move only left and right. And we said maybe the way that it's being manufactured is perhaps there is a hole inside this cylinder there, like that. which this link one, it passed through that hole there, right? And we said we were gonna, if you cannot visualize it now, don't worry, we'll talk about it in more details later. And another way to show this mechanism is just to tell people that this link, this member 4 is being constrained here and there. Also, I said sometimes just out of laziness, we don't show the top part here. It doesn't mean that member 4 can move up. It's just a way for us to show it. It doesn't mean it's not there. So these are just the symbolic way to show an actual mechanism, all right? So this mechanism, if I want to quickly, let me see if I have perhaps a video here that I can show you. Chapter 1. It's, yeah, it might be something, I guess, hopefully on YouTube, I guess, on this one.
Make money doing absolutely nothing. Yep.
Sorry for the ad. That's something that we had to watch it before to watch the actual mechanism here. So see the mechanism. This is the same slider mechanism. You see this link goes back and forth. Sorry for that extra video there. All right, and I have a slider mechanism also in my lab. Which I posted a similar video on Canvas as well for you if you are interested to watch. If you are interested, you can actually come to my lab and see it and play with it. All right. So more mechanism here, like what we said in the class, this portion, it's not there. And this portion also is not there. This is the actual mechanism that we see. And ground is what I highlighted here, but those parts are there. We just don't show them. We talk about the cam and follower mechanism in the class and other mechanism as well. All right. Now, real life examples. If I can sort of stop sharing here, and perhaps I switch my video. All right, sounds good now. You should be able to see pliers here, like this is a regular pliers that you can see it maybe in a shop or somewhere. Now, okay, what I asked you in the class to see if you can find the 4-link mechanism here, and some of you managed to find that 4-link mechanism. I'm going to show it one more time here to you. So first of all, we fix this one to the ground. That's part of the ground, and it's fixed now there. Okay, so I have one joint here. I have another joint there, and I have another joint there. There is another joint which we cannot see. It is inside and it is there. So what I have here, actually, this is one link there. This is the connecting link. And this is another link, which that link is more like a plate, like that link. And also this link is more like a plate, a larger link, like that. All right. So you should now notice the 4-link mechanism here. All right. So the 4-link mechanism, as you can see it in this plier. So one thing which one of your friend asked at the end of the class was, what's going on with this spring there? All right. So there is a little spring inside each plier. Remember that spring, it just creates a resistance, but it does not interfere with the regular motion of this mechanism. So in other words, in this course, keep in mind, whenever you see a spring, just ignore it. That spring is not going to interfere with the movement or motion of a mechanism. It just create a resistance. Of course, it change the forces, but regarding the motion, it does not do anything. So whenever you see a spring in a mechanism, it has no effect and just simply ignore. All right, going back to sharing my screen. If I can do that. Yes, sharing my screen. All right. So let's just show that one more time here. I know it's becoming boring, but this is a part that we fix it to the table. This is now being fixed. And we have one link there. All right. We have like this plate there. Let's just maybe highlight that plate color. So see, this is a plate, or maybe just a bigger link there. And we have this other link. All right, sorry. We have other link, which the other link also is a plate, is not a link there, right? So this is a plate there. I'm going to show you the joint. Of course, this joint, you cannot see it. It's inside. This is another joint. That's another joint. And that's the joint there. So you see, there is a four-link mechanism. One is my ground. This is link number 2. This is link number 3, like the whole things. This plate is link number. I call it link, but it's a member number 3. And this is member number 4. So member number 3 and member number 4 are not just a simple link like number 2. Okay. And we said, pay attention to the spring here, that the spring does not create any constraint of motion, right? It's not going to have any effect on the general motion of this mechanism. It just creates a resistance, which a discussion for later topic. Okay. All right, so let's move on to the second example, which I showed you in as well in the class. I'm going to stop sharing here. Let's put that aside. And all right, so this is a mechanism, as I showed you in the class. I use it every day. I love walnuts and eat a nutcracker. So I'll just simply put a nut there. And if I apply load, I'm just going to crack my nuts. So, and enjoy eating it. Anyway, so I'll eat it later. And this one also, as we discussed in the class, it's another mechanism which in the class, majority of you could guess. It's a slider mechanism. Let's go back to my sharing the slides. All right, so this is a mechanism there. Let's just do a little bit of drawing here. I have that link there. And that big link there, I have another link there, and inside there, there is this little box there, and obviously as part of the ground, that little box is being fixed or being constrained So we have joints. Let me just quickly show the joint here, the joint there, and the joint which you cannot, of course, see there. And if I bring it down so you can see it better, this is what we have for this mechanism. I apply a load, let's say somewhere there. I apply a force here, F. A result is going to be a force there, which is where the walnut is, right? If you push down these things, then of course this piston wish to move to the right, and this is where your walnut is gonna sitting there. This is your imagine your walnut. Oh, it's not a walnut. Sorry for my drawing. Let's do a better job of the walnut drawing. So this is the walnut, and of course on the other side of the walnut you see a wall. So this is a wall, and you crack your walnut. All right, so and this is on the right. You see a complete version of it, which geometry is a little bit different, but they are all the same points. Now, if I want to show you, let's call this one point A, point B, point C. This is going to be point A, point B, and point C, which you cannot see. It is inside. This is point A, point B, and this is point C. And obviously, this is also attached to the ground, and you see this is a joint there. So the one that you saw it here, it's a different geometry, but they are all the same. It shows a different position, and maybe the length AB is longer in this mechanism that I showed here. So you see some angles here and some parameters, alpha, gamma, and beta there, and the distance B and A. Later, we will come back here and we will calculate together the ratio of your force, that if somebody apply a load F in, how much force you get F out. And actually, I will show you how you can attach maybe a sensor to measure the force. All right, so we'll leave it for now here. It's just important to understand how this mechanism works, as I showed you earlier. All right, so this is a loader mechanism. You may stop the video for a second, and let me also switch my video there. All right, you may stop the video and think about this mechanism. The only things that you need to pay attention to this mechanism are those piston 1 and piston 2. Those are called hydraulics. What is a hydraulic? So inside these cylinders, there is a piston. So think about like this little piston inside there that can move ups and down. So this little piston there, and it is this piston that is being connected. So that link is there. All right, so we have our piston there. This is the piston there. And on the back of this piston, there is oil, actually. That is oil there. And somehow, with some hoses, we control the amount of oils there, and that oil is helping with us pushing this piston ups and down. We have a similar mechanism down here. So another piston there. This is our piston there, and on the back of it there is oil. And the discussion around hydraulic is out of the scope of this course. You have in future actually a course on hydraulics, which discuss this mechanism in more details. But for now, it's important for you, for the discussion that we have, whenever you see a hydraulic, they made out of two components. One is the cylinder, the outside cylinder, and the second one is the piston and the link inside it. So there are two members there, right? So if I want to count the number of members in this mechanism, one is the ground, right? Which is actually the entire frame of this machine being fixed to the ground. Maybe this entire mechanism or this machine is on a ground, on a fixed ground, not moving anywhere, and we put on a brake. Maybe we put something here to stop this machine from any motion. That's why we show this sign to tell people that this machine is not going anywhere. So the whole thing is part of the ground. Now focus on this mechanism. So I have a joint there. I can see another joint there, a joint here, a joint there, a joint, a joint, a joint, and a joint there. All right. So this mechanism then made out of member number one, which we already called it. And then we have, let's call this one member number two. It doesn't matter the order, how I start. This is member number three. This is member number four. And remember, member number four is not a straight link. The entire thing is member number four. All right. And then I have member number five. All right. So far seems to be easy and good. This is what I want your attention. This is actually member number six, that link and piston. And then the cylinder, the outside cylinder, is member number seven. Similarly, over here, I have member number eight, and then member number nine. So if I ask you how many members this mechanism has, your answer should be 9 members, including the member one there. And how many joints do we have? Let's count it. 1 joint, 2, 3, 4, 5, 6, 7, and 8. So I'll do it again. 1, 2, 3, 4, 5, 6, 7, and 8 joint there. How many slider we have? We have 1 piston and cylinder here, and we have another piston and cylinder there. All right. Next time when you are in a gym, pay attention to this elliptical machine. Most of gyms, they have this machine. And I want you to maybe stop the video and think about this mechanism again. And maybe on your own do an analysis of the motion of this mechanism. And then watch the rest of the video. All right. Now let's say you stop the video, you come back to watch it. So this is one link there that I have. Okay, so this is one link there. The link is being joined to the frame and it can rotate. So obviously, this is not just a link. Maybe if we want to be more exact, this is actually maybe a disk, all right? So that disk, the entire disk is being joined and rotates. But for us, we can just treat it as a link, all right? We can just treat it as a link. Doesn't matter the motion. And then it's important to pay attention that this is another link going all the way there. Oh, sorry for that. Okay. And let me finish up this last link there. And now let's focus on the joints. I have one joint there. I have another joint there, a joint there, and a joint to the ground. So keep in mind that this is the main frame of the machine that's fixed on the ground. So it means this portion are also fixed to the ground. So what it means? It means that actually this joint is being fixed to the ground because it's fixed to the frame of the machine. Let me just move everything to the side. It's better to see it over here. All right. So this is actually the mechanism that we have. So we have, I don't need the ground anymore there. Let's just leave it there. Right. So what I have here, I have ground 1, member 2, member 3, and member 4. So this is a 4-link mechanism actually. Okay, so that's 1. And if we want to just call this point, let's call this one point O, A, B, and C. So this is point O, A, and B there, and point C there. Okay. And again, as I said, this circle it shows the motion of point A, which is a circular motion. But for us, it doesn't matter, right? What it matters is that we have a link to there. Right? And of course, this is where the standings happen. And one thing that I want you to pay attention, this mechanism, the entire machine made out of 2 mechanisms. They are parallel. You see, one is for the right leg and one is for the left leg, of course. So these 2 are parallel with a little bit of lag. So it's a very interesting mechanism. I encourage you, go to a gym. If you're not a gym member, it's good to do some exercise. And a good chance to also see an elliptical machine, an amazing machine, which is actually nothing but a 4-link mechanism. And you will see later in the course how we can actually model it to see why it's called an elliptical and why the motion here is an elliptic motion, and then what sort of motion or swinging motion you see there as well. Okay, for now, it's just important to understand the components in this mechanism. There are some fun mechanism here for you on YouTube. Just play them on the slides and watch them in your own time. Okay, I'm gonna stop sharing there. Thanks again for listening. And as I said, please watch this video. If you have any question, you can email me for office hours. And of course, during the lecture, we're going to come back to these a lot, like that walnut cracker. We're going to come back and do the calculations, have some fun with it. And maybe I'll show you how you can attach force sensors to when you crack a walnut, how to measure the amount of force that you apply to a walnut. All right, just as a fun experimental test to do at home, maybe. All right, I'm going to also post the annotated slides on Canvas for you as well. Have a wonderful day. Thank you very much.